But glad to have Krishi Sharma to talk this morning. I don't want to take up too much time to introduce her, but let her introduce herself through the topics that she'll be sharing with us. Okay, Sharma.
Hello. You all hear me? Yes. Okay. Hi, I'm Krishi, and I'm here to talk today about MLFlow. MLFlow is one of my favorite packages for machine learning. But before we get into the specifics of MLFlow, I wanted to talk about why it's important and what it can really provide us, what the value is. And to do that, I want to talk about trust. So this is Elizabeth Holmes. I'm sure many of us recognize her face. She was CEO to the former, or now defunct, biotech startup, Theranos, which sought to revolutionize the medical industry with its innovative blood sampling techniques. She garnered a ton of enthusiasm and interest from her community, from the public, and from the media, and soon was raking in a lot of money over all of the excitement that her tool and her innovation promised to bring. However, all of that collapsed when the trust was lost in her product. It turns out that she didn't have the metrics to back up her claims, and that her product didn't actually do what it said it would do. There was no documentation, and there was no scientific reasoning that people could follow. And that led to a drop from $9 billion in valuation to zero. So without having metrics to back up our experiments, and without having a way to communicate what we've gone through and how we've come to the final process that we have, it can be really difficult to retain that trust and that valuation in our products. And so building trust is critical to the success of our products and to retaining that valuation. So now that we know that, the real question is, how do we build trust? What can we do in order to make sure that we have clean documentation that people can follow? And the first thing is to make sure that you keep your paper trail from day one of your experimentation. To make sure that you have all of the metrics, all of the different processes and tools in place so that people can follow your train of thought from when you started to the finished product. The second one is reproducibility. This is to make sure that people can follow what you've done and be able to validate your results. If somebody can't validate your results, then how can people really know if those metrics are fake or if they are irreproducible and you cannot get them again? And the last one is transparency. So all projects are a work in progress, especially scientific ones. And so how can you know where you are in that process, what the challenges and weaknesses are, and where you're planning to go further? What's the next iteration? So we've talked about why we need to build trust and how we build that trust. The rest of the talk is going to be around what tool can we use to build that trust, particularly in machine learning projects. So with machine learning projects, there are three main components. The first one is code. So the code relating to the training, pipeline, and data preprocessing, evaluation, prediction. All of that code can kind of lead to a lot of communication between your team and can quickly change over the course of a project due to the experimental nature of machine learning. The second one is your input data. So this is the raw data that you put into your training pipeline in order to train your model and then evaluate on it. That can go through many iterations depending on what the project is and how far away your raw data set is from the clean data set that the model needs for training. And the third one is metrics. With machine learning, we want to see what the model performance is and how to improve that over the course of our experimentation. So how can we properly keep track of those metrics in a way that people can follow along with how we improved our model over time and what we did to improve that model? MLFlow specifically helps us with the metric tracking component. So instead of having to figure out how you're going to store your results, whether you're going to use a database, whether you're going to somehow use some other tool within your team, or if you're going to go low tech and use Excel, whatever it is, MLFlow actually helps you by abstracting away all of that decision making around how to store the data, and instead gives you defaults that it uses to store those metrics and that data for you. It does this through an artifact storage that it creates upon startup. So once you initialize MLFlow within your project, it will automatically give you an MLRuns directory. This MLRuns directory will contain relevant metadata to your project and will have all kinds of different artifacts that you're planning on logging, neatly organized depending on how you've named your experiments. And the second one is a database. The default is SQLite, but you can actually plug it into whichever database you want, and you can share it amongst your team depending on if you have a server for that database. The MLRuns artifact storage looks like this. This is like an example within a repo. So this would be contained within your project root directory. And you could have things that are called experiments. Experiments are grouping of different trials. So if you have a particular idea on how to improve model performance, you could group it under maybe an experiment called exploration. And that could be used to kind of iterate through different combinations of hyperparameters or maybe different input data, pre-processing steps, whatever it is. And each of the trials in MLFlow are called runs. So with MLFlow, they prefer to use the word run for each trial and experiment to group all of these runs. And then below you can see that we have the MLFlow.db, which is the SQLite database that it creates on startup. The MLFlow database contains a lot more granular data around your model. So it contains any tags, if you register your model, all of the parameters that you choose to log, and all of the metrics in a way that you can quickly query amongst the tables. So my team has found that particularly useful whenever we've needed to find really granular level data in our experimentation. MLFlow also comes with a UI. So every time you start up your MLFlow project, you get this UI that groups things under experiments. So this experiment has 4 different runs. And each of the runs will be given its own user-friendly name, when it was created, and how long that run lasted. It'll also have a set of parameters, whatever you've chosen to log in your Python code, and whatever the metrics are that you've chosen to log. Besides those infrastructure components, MLFlow also has a CLI that's really easy to use. So a lot of what we're going to be talking about today is actually using the Python API, but if you feel more comfortable using the CLI, it also has that. MLFlow also supports PyTorch, TensorFlow, OpenAI, and LLM. So the last 2 are recent additions, but it basically allows you to log parameters according to the specific framework you're using, and it automatically picks up on that. And then it also features both a high-level and low-level API. The high-level API is if you want to do really generic, basic commands to log your metrics and parameters, and the low-level API is if you want to do more complex tasks, such as create a model registry, both of which we'll talk about. So I was trying to decide exactly which features to highlight. And the way that I really came upon it was I realized that there was one project that encapsulated all of the features that I felt were most important and in some ways kind of hidden gems. And that was on a project at my company, Kung Fu AI. The project was called, well, we're calling it Project Llama for today's talk. It wasn't actually Project Llama. But Project Llama was a year-long endeavor in which we were tasked with creating a machine learning model using radar data. And we wanted to predict debris on runway. The task was pretty complex because the data was very noisy and a lot of it felt unusable. So we weren't exactly sure how we were going to solve this problem and how much we needed to do in order to properly train the model. So we put a lot of our developers on this project and got to work. We did a lot of exploration to figure out how on earth to clean up the data and how it would train when we just used maybe basic preprocessing and raw data. So we built up our training pipeline and we decided to use MLFlow to start logging things. We've used MLFlow in the past, so we started using it the same way we've always used it. For those of you who haven't used MLFlow before, MLFlow basically has these functions within Python. So log param will allow you to log parameters. Log metric will allow you to log metrics. And each time you want to log something, you can put one line in your Python code to log it. You can also log multiple things at once. It just depends on how you want to structure your code base. So for our project, we had all of these different logging lines. And because we're in the exploratory part of the project, each of our developers had checked out a different branch and were logging different things. And all of a sudden, our MLFlow database kind of started feeling like a mess. So we had to figure out how to make something that was really chaotic with logging into something that was a little bit easier. And that's when we came across hidden gem number 1, which is MLFlow's auto logging function. So MLFlow has custom logging, which is what I showed earlier. But its auto logging function is super helpful because it allows you to automatically grab all of the parameters and metrics that you want to log, and it'll put it in the database for you. So rather than having to come up with all of the different parameters and list them out manually, you can just use this MLFlow.autolog within your Python code, and it'll detect which framework you're using under the hood, and then grab the relevant parameters accordingly. So we found that with using this one line, we were able to have consistent logging across all of our branches throughout this experimental phase of our project. This made logging a lot more thorough while having less lines of code related to the logging, which helped with the technical depth. As we progressed within the project, we went from having the exploratory phase more into developing the actual training pipeline. So now we were kind of working on how to fine-tune our model and find the best model performance and metrics in order to kind of close off the project and deliver it to the client. To do that, all of us were working on the training pipeline and testing out different hyperparameters. And it seemed a little bit like maybe we wouldn't get the parameter or the metrics that we wanted, until one day one of our developers came across a really great combination, and we were able to, and she had tweaked her training pipeline in a way that we were able to get a really good performance. And this was really awesome because we felt like we were much closer to finishing the project than we had originally anticipated. The developer later left our team, and within the next few weeks, we wanted to validate all of the work that she had done, and also all of the work that we had done, in order to make sure that we truly had a model that we could deliver. However, she didn't really leave much documentation, and we didn't have much of a documentation process in place besides MLFlow. So while we had all of the metrics documented within our UI and our database that MLFlow had created for us, we didn't have a good way to tie back those metrics to the code. It kind of felt like searching for a needle in a haystack when it came to finding the combination of code and metrics that she had used. We didn't know which commit contained all of the work that she had created, or if she had even committed her work at all. We didn't know which branch to look in, so it took us around a week of searching in order to try to piece together the training pipeline code. And we were never able to fully reproduce her results. That became super problematic because if you don't have reproducibility, then you don't have true trust within your final product. And that's when we realized that while MLFlow was amazing for tracking metrics, what we really also wanted it to do was to somehow tie those metrics to the piece of code that had generated those metrics. And that's when we spent a lot of time looking through MLFlow's documentation and tried to figure out if they were already doing this under the hood for us. And it turns out that they kind of were. So hidden gem number 2 became MLFlow's tagging system that automatically captures metadata related to your code base. This up here is a key that you can use within the tag that you want to set. And it will automatically capture the git commit that is related to the MLFlow run that you just executed. So all you have to do is do mlflow.setTag and use this as your tag. And what you will get is a new column in your MLFlow UI that has all the tags that you decided to log. So now we see that we have a git commit hash tag, and our team also likes to use the run ID instead of the run name. But now you have a one-to-one matching between the git commit that was used to generate the MLFlow run or run ID. This made it a lot easier for us to then figure out how to go back and validate our code. We didn't have to go and communicate through Slack or search through our Git history or talk to each other about how to maybe piece together the code for validation. But we also realized that it would only work if we were properly committing to our repository. If you only made commits every so often, then your commit wouldn't necessarily encapsulate all of the changes that you had made before kicking off a series of MLFlow runs or an experiment. And so we wanted to figure out how we could remind our developers on our team, while they were quickly iterating over the machine learning code, to also remember every once in a while, before they executed their MLFlow experiment, to commit all the changes. And the way we did that was actually through a shell script, which reminded developers to commit every time before kicking off any training job. And so they would be reminded that they had changes within their working tree and that they should commit them just so that they would have a clean working tree and therefore a commit that completely represented all of their changes. And we've been using that for a little while, and it's actually really helped and made it a lot easier to tie back the code to metrics. So we found that we had a lot less dev time wasted searching for the code, and we had better alignment between the training pipeline code and the model performance. So now that we had a model in place and we had actually validated that model, it was coming to the end of the experiment and we were getting ready for deployment. All we had to do was clean a few things up. And anybody who has done production-facing projects, I'm sure, will understand. But this part is a lot easier said than done. And for us, that was particularly true, because we found that it was hard to package up our model with all of these MLFlow runs that we couldn't really figure out how to properly document and display to our end client. And so that brings us to the third MLFlow hidden gem. we really wanted to figure out a way that we could kind of highlight the most important runs when we were coming up with our documentation and presenting it to our customer. We wanted to do something kind of like in code where you could tag a particularly important Git commit and say like, hey, this is related to an important change, almost like versioning our model. And it turns out that MLFlow has a model registry, and you can register your model using the model registry. So this will keep track of the important milestones that you've hit over the course of your MLFlow project, whenever you decide to put this command in your code. And all you have to do is give a name for your MLFlow model and the run ID associated with the model that you're trying to log. And it'll log that model within this new window that looks like this. So your MLFlow registry will contain the different versions, and every time you give a new run ID with the same model name, it'll bump up the versions for you. And it will also keep track of the stage of the model. You can control the stage of the model either through the Python code or the CLI. But as you can see here for Project Llama, we have 4 different versions, and the one that's in production is version 2. We can then kind of go back and tie the version back to the run ID, so that way we could show the client exactly how the model performed over these different versions and how we got to the version that we got to. So this made documentation around milestones a lot easier, because now we weren't just giving them a whole database of 1,000 different runs. And we were giving them only the few runs that made sense, the ones that actually captured the highlights of the story of our year-long project. So this made it a lot easier. It also made it a lot easier for us when the client came back and wanted to work with us more on this project, because now we had better searchability over our MLFlow runs. All of these changes that we implemented saved us a ton of development time, because we were searching a lot less through our code, and we were having to do a lot less cleanup around our code, because we were doing it throughout the project using these different commands. It also built more confidence in our metrics, because we had a more robust validation system due to the fact that we had a better picture around what the code was that was used to generate each of these metrics. The metrics weren't just standalone anymore. And overall, it instilled trust in our process, both internally on our team and also externally with the client. So it made it a lot easier for us to gain their trust and have them work with us again. These are some additional tips that we learned when working on Project Llama. And the first one is to back up your MLFlow database. This one may seem kind of obvious, but I have to put the obvious in there because it sometimes happens. We were working on Project Llama midway when our database for MLFlow was deleted. I don't know how it happened, but out of many developers, it just happened one day, and therefore all of our run history went away with it. And that meant that it was a lot harder to document that part of the process, because now we had to go reproduce those results. It also took up some time, because now we had to go figure out exactly where we left off in our experimentation. So just make sure to back up your data flow or your database. The second one is to commit frequently. So like we talked about before, with the git commit hash, it's most useful when it captures the actual state of the code at the time of the MLFlow run. So I would just recommend having some kind of safeguard to kind of remind your teammates or yourself to commit before you run a big training job where you're planning on sweeping through a lot of hyperparameters and probably making some important changes that you might want to go back and validate later. And the third one is to version your data. This project was pretty complex, and we had a pretty big data pre-processing part of our project. So that means that you could have different versions of your data that you might need to use within your trading pipeline. And so having a version of your data will mean that you have better alignment understanding not just the coding and metrics, but also the exact version of data that was used. So you can use MLFlow's artifact logging if you have a smaller data set, or a different tool like DBC or cookie cutter data science. But I would just recommend using something. Overall, MLFlow helps build trust within your process and your metrics because it gives you a way to cleanly document your milestones and make sure that all of your teammates are on track with where you're at in your experimentation, and that your client or your end customer understands where the model performance came from. So I have a GitHub repo that kind of goes through all of the MLFlow hidden gems that we talked about today. So feel free to copy down the tiny URL that takes you to that repo. It is within a containerized application, so it's already Dockerized and has MLFlow and all of those commands within a working, dummy model. The second one is my contact, and the third one is Kung Fu AI, which is a company that I work with. It's an AI consulting firm, so if you want to learn more, come talk to me about it. Otherwise, I'm free for questions. Yes.
Obviously, I think we consider other solutions like
You need the mic. Sure. Now, come back to you.
yeah, I can just speak up to if you consider solutions like BBC, and I wonder how you think they compare, and also compare with them, and also weight and biases. Also, another question is how do you consider using just to tie your code data and all of it?
I can't hear the last part.
Oh yeah, the last part is have you considered using just Git to tie your code, data, and model together in one place?
Okay, so I think your first question was, have we considered alternatives like weights and biases, and did you mention DBC?
Yeah.
We have used DBC in the past, and DBC is a great tool. It's more of a CLI. And we found that it was a little bit difficult for our developers to really adopt for some reason. I think that it works a lot like Git, which is great, but it requires you to have cloud storage set up from the beginning. And for some of our projects, we were in experimental phase, and we didn't always have somewhere to store it. And I think that we just wanted to find a way to kind of use everything within just one package, so MLFlow worked. And weights and biases is an alternative to MLFlow that we have used on FFP projects. We mostly tend to use MLFlow because it's open source and free, and that part is really awesome. And it has the functionality that we need. Weights and biases has, I think, more functionality around visualizations, but we've actually been able to kind of do what we needed to with MLFlow without having to pay for the package. So those are the two reasons. I can't remember your last question.
Well, yeah, the last question is have you considered using Git to version control all the three components you have, code, data, and model?
Yeah, so we have used Git to version our code and our data. We just use a basic nomenclature to kind of figure out our data, what stage it's in, whether it's the raw data, pre-processed data, whether it's the final process data. So we've used Git, especially when the data set is small enough. That is a great tool. But for the actual metrics itself, the reason that we wanted to use something like MLFlow is because it provides more visibility easily with the dashboard component, and it provides easier searchability. You don't have to go and create the schema for your database and figure out how to relate the tables or all of that infrastructure underneath. And it also comes with functionality for free, whereas if we were just tracking the metrics on our own, we'd have to go and figure out are we going to use Excel, or are we going to go export it to a CSV and stuff like that, and that became a little messy with the projects that we used prior to implementing MLFlow. So this was kind of an easier way, and it also allowed people outside of the engineering team to understand those metrics, because a dashboard is easier to understand than like a Canvas data frame for like maybe a project manager who would want to know the metrics but may not have that kind of like understanding of some of the tools that the engineering team uses. Does that make sense?
I think that makes sense. Thank you.
I have a question back here.
So I actually had a very similar question, and I think I could actually, we had a specific period of time where we were trying to use DBC, but we have a lot of sensitive data, and we need to be able to locate that data like on a moment's notice. So because DBC is more file-based, we didn't have this kind of lineage and governance that you might find in something like MLFlow.
Oh, that's really cool experience to know about.
Any other questions?
Thanks. Great talk. On the reproducibility issue, obviously you learned some of that the hard way, and thanks for sharing. So maybe some of the rest of us don't have to. I wonder, given your ability to record that, what is then the process of reproducing, and how manual or automatic is it? And is it sort of a one-time thing you do right before you release to production, or is there some continuous process that sort of, much like testing, sort of says, don't rerun everything we've done in the past, but maybe some of the top performing ones, run them every night or once a week and make sure they're still working properly and getting the results we expect?
That's a great question. So our validation process before using this new MLFlow, trick that we learned was to basically go and right before the project deadline, because our projects are not typically a year, they're shorter. So this one was a little bit of an anomaly, but right before the project was going into production, to make sure that we ran validation. And so the way we would do that is actually through just like communicating with each other, like, okay, so we see an MLFlow, this is our top model performance, let's go and use those hyperparameters and use whatever's in our main branch and see if that will reproduce our results. And the reason that that didn't necessarily always work on a longer term project like Project Llama was because we wanted to run validation a few more times in between the process of a year. And so every time we would have kind of like a discussion with the client right before that, we would want to run validation to make sure that whatever we were presenting made sense. So that was kind of how we anchored when we ran validation, was based on like kind of the quarterly meetings that we have. And with this new trick, once we learned just how hard it can be to piece together the code, if you don't have like the most perfect Git flow during your highly experimental phase of your modeling process, with this new thing, then we started right before we were going to meet with the client, we would take that Git commit hash, and somebody would be tasked with trying to make sure that they can reproduce those results using the Git commit hash. So they just check out that commit, and then we run the training pipeline using the config that was necessary, if that makes sense.
So thank you for the talk. Question on the auto logging portion that you covered. I'm assuming that it goes through the model that you're using and tracks anything within the framework you're using that's thrown into the model. Will auto logging catch anything outside of that, or do you have to still log that manually yourself?
If it's outside of the frame, do you have a specific example?
So maybe you want to, so you may compute your metrics, right? You may not throw those into the model, but maybe an evaluator. But you may also have some metadata that you're not maybe wanting to, for either privacy reasons or personal reasons that you want to track that's not going into the model. Maybe you want to name a particular thing. Like would you have to manually say you want to log those with the function, or does auto logging just catch anything that's a variable within the model?
That's a good question. You have to probably manually log it. From our experience, it works within the defaults of whatever the framework is that you're using. So that's a good question. But you would have to manually log it if they're not within that framework, and that, or maybe sensitive. But it does have a lot of metadata under the hood that it collects. It also doesn't automatically just render those to the UI. The git commit hash is an example of something that it is collecting under the hood, and it has the ability to track, but it autolog doesn't automatically just show you the git commit hash.
So I guess that also would imply that you haven't seen a scenario where you would need to log something that MLFlow autolog hasn't captured then.
Wait, sorry, can you ask the question again?
Yeah, sure. So I'm guessing by your response that you have not encountered a scenario where you wanted to log something that MLFlow wasn't already captured.
Not for our projects.
Okay. Okay, thank you.
Any questions, any hands raised? See what?
I wanted to ask for MLFlow, does it provide any mechanism to do like logging after you've like shipped your ML model, assuming that like you're bringing these into production, and any workflows there?
Actually, yeah. So it does allow you to log your model checkpoints, and it'll save those as like files within your artifact storage. And you can basically use those, you can push those model checkpoints to production. We don't have, I don't have as much experience with that portion. We don't use that part, but they have like thorough documentation over it, so they definitely do it.
Do you know if like, I don't know if you've worked with this before, but like, do you know if like people would use this to like retrain models like with like production data as well?
With production data, I mean, I think you definitely could. I don't know if people use it like that. I don't think it's as common of a case from all the experience I've had across the organizations that use it, though.
Okay, got it.
No more questions? No, thank you.
Thank you so much.
Thank you.